Hello everyone, myself Purva Apte from D.E.S Secondary School, Pune. Today we are going to begin with the third lesson under Science 1, that is chemical reactions and equations. In the earlier standards you have studied about what do you mean by compounds, how the bonding takes place. So this year in this lesson we are going to study about the different types of chemical reactions and also how to represent these reactions in the form of equations. So let's switch over to the presentation. Usually, whenever chemical reaction, the word comes in front of us, immediately colorful solutions, test tubes, laboratory, all these things come in front of your eyes. But do you know these chemical reactions are taking place around us also? We can feel them, we can see them. First, these are the basic examples of chemical change. You will be surprised to see that ripening of a fruit, height of your friend increasing or you are increasing in your height, a vegetable getting cooked in the kitchen. These are all the examples of a chemical change that is taking place in front of your eyes. One more type of change we usually observe in our day-to-day activities is physical change. Water turning into ice, condensation of water vapor, breaking of a glass jar at home. These are all the examples of physical change. Physical change is a reversible change and chemical change is irreversible change. Chemical reaction, when we say, it is a process in which substances undergo bond breaking and transformed into new substances by forming new bonds. That is called as a chemical reaction. A chemical reaction can be represented as an equation which we call as chemical equation. Here you can see I have written C plus O2, that is carbon plus oxygen. When react together, they give carbon dioxide. So this complete reaction can be given in a small equation, that is C plus O2, that gives CO2, that means carbon dioxide. Now how to write chemical reaction? In a chemical reaction, reactants are written on the left hand side and products are written on the right hand side of the equation. Here at the bottom, I have written one particular equation, that is CuSO4 plus Zn. It gives ZnSO4 plus Cu, that is copper. Here you can see the reactants are written on the left hand side. That means CuSO4, copper sulfate, and zinc are the reactants, and ZnSO4, that is zinc sulfate and copper, are the products which are written on the right hand side. Now this left hand side and right hand side is connected with an arrow towards the product side. So this is how we can write a chemical reaction. There are some more rules and regulations for this as well. If reactants or products are more than 2, they can be separated by a plus sign in between. Here also you can see there are 2 reactants together, so they are separated by a plus sign in between. So again I repeat, CuSO4 plus Zn, it gives ZnSO4 plus Cu. Some more rules for this. To make it more informative, physical states are written in the equation. For example, L in bracket for liquid state, S for solid state, and G or an upward arrow for a gaseous state. In the reaction given below, you can see I have written over there copper sulfate AQ, that is it is aqueous solution, that means solution made in water, plus Zn, I have written in bracket S, that means it is in solid form. We get ZnSO4, that is zinc sulfate, again in aqueous form, and Cu, that is copper, in solid state. So we can make the chemical equation more and more informative. Also, some specific conditions, like some specific pressure is required or specific temperature is required for that reaction, it should be mentioned in the equation. Now the example which we have written here does not require any specific temperature or pressure, and so it is not mentioned there. But in the due course of time, you will come across such reactions also. Now, how to balance a chemical reaction? Once we are comfortable in writing the formulae for the different reactants and products, now we will be switching over to balance the chemical reaction. Steps in balancing the chemical reactions are, first is compare the number of atoms on the reactant side and the product side. In 9th standard, we have studied the law of conservation of mass. That means whatever amount is added as reactants, we should get that much amount of mass in the product side also. So here is an example, NaOH plus H2SO4, it gives Na2SO4 plus H2O. Here we are going to compare the number of atoms on the reactant side and the product side. The first one, Na, that is sodium, number of atoms on the reactant side is only 1, but in the product side we can see that there are 2 atoms. Oxygen on the reactant side, they are 5, and on the product side they are 5. So oxygen is already balanced here. In case of hydrogen, if we observe, on the reactant side they are 3, and on the product side they are 2. And S, that is sulfur, it is only 1 on the reactant side as well as on the product side. Now from this table, it is very much clear that sodium and hydrogen are to be balanced. Okay, so let us move ahead. If we take 2 molecules of NaOH, we get Na balanced, that is sodium gets balanced, but the balance of hydrogen and oxygen is not attained. So to balance hydrogen, we can put 2 molecules of water to the product side. Then the reactant side atoms and the product side atoms could be balanced in this way. So the reaction can be given as 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Now if you compare all the reactants and products side for different atoms of elements, you will observe that sodium, oxygen, hydrogen, sulfur, all are getting perfectly balanced. So this is how you can balance a chemical equation. Now coming towards the different types of chemical reactions. Chemical reactions are classified into 4 types based on nature and the number of reactants and products. So those 4 types are combination reaction, decomposition reaction, displacement reaction, and last, double displacement reaction. We are going to study in detail about all these 4 types of chemical reactions. Combination reaction, as the name itself suggests, combination, that means combining 2 different reactants. If you remember the definition according to the meaning of this particular words, it is easier for you to memorize the definitions. So as I said, combination, it is combining 2 reactants. So when 2 reactants react together to form a single product, then this reaction is called as combination reaction. For example, if A is one of the reactant and B is another reactant, they combine together, combination reaction takes place, and product AB, that is single product, is formed. For example, C plus O2, that is carbon plus oxygen, gives CO2, that is carbon dioxide. Also, the reaction 2Mg plus O2, it gives 2 MgO, that is magnesium oxide. This reaction you must have tried at least once in the laboratory in the previous years also. One more reaction is CaO plus H2O. It gives CaOH twice plus heat is released in this. As product is only one, that is calcium hydroxide, this also comes under the category of combination reaction. Here we have the example of burning of magnesium ribbon. You must have observed this reaction at least in your previous standards. Here we have taken a magnesium ribbon and we are trying to burn it with the help of a matchstick. Let us see if it catches fire. Yes. Now it is burning and you can see a white colored fumes appearing. Here magnesium is burning and the oxygen which is present in the atmosphere, that is it is reacting with it, and a white powder of magnesium oxide is formed. A very quick reaction of combination reaction type, that is burning of magnesium ribbon. Let's move ahead for the next type, that is decomposition reaction. As the name itself suggests, decompose, that means a single reactant is getting divided or is getting decomposed. So the definition is a reaction in which two or more products are formed from a single reactant is called decomposition reaction. Example for this is C12H22O11. It gives 12C, that is 12 carbons, plus 11 H2O, that is water molecules. Here single reactant is getting decomposed to give two or more products. One more example is regarding water. Water molecule, that is 2H2O, when it undergoes decomposition reaction, it gives hydrogen and oxygen, that is 2H2 plus O2. CaCO3, it gives CaO, that is calcium oxide, plus carbon dioxide. The general form is also seen on the slide, that is AB. When the decomposition reaction takes place, it gives A plus B as products. Let us see one more example of decomposition reaction, that is decomposition of water molecule. We know that water does not carry electricity if it is distilled water. But if it is acidulated or a pinch of salt is added to that, electric current can pass through it and the decomposition of water can take place. Here we can see electrolysis of water, that is decomposition of water. As we are using electricity here, it is called as electrolysis. Here you can see that as soon as the electric current passes through it, water gets dissociated or decomposed in H2 and O2 and they get accumulated at the respective electrodes. Now the next type is displacement reaction. Again, the word itself is telling the meaning, that is reactants are getting displaced and they are forming new products. A reaction in which the place of an ion of a less reactive element is taken by another more reactive ion. It is called as displacement reaction. Examples are CuSO4 plus Fe, that is copper sulfate plus iron. When react together, displacement reaction takes place and it gives FeSO4 plus Cu, that is iron sulfate plus copper is separated out. Here the copper is getting displaced and iron is taking its place, and because of that iron sulfate, that is FeSO4, is formed. In the next example, you can see zinc plus HCl, that is hydrochloric acid, react together to give zinc chloride, that is ZnCl2 plus H2. Here, hydrogen is getting displaced and that place is taken by zinc. Thus, zinc chloride, ZnCl2, is formed and hydrogen gas is released. This is the general form of the type displacement reaction. Here we have one more video to show displacement of copper by iron. This reaction you must have seen already. We are just going to demonstrate this.
Uric acid, iron nails. Method. Take a beaker and in it pour 50 ml of tap water. Pour 1 to 2 spoonfuls of copper sulfate crystals in the beaker and stir well. Add a few drops of dilute sulfuric acid. You obtain acidulated copper sulfate solution. Take out about 5 ml of the solution in a test tube for comparison. To the rest of the copper sulfate solution in the beaker, add 2 lightly polished iron nails. Cover the beaker with a paper and leave it undisturbed for half an hour. Now compare the color of copper sulfate solution with the test sample in the test tube. Take out the nails and observe their color. You notice that the blue color of the copper sulfate changes to light green color. The brightly polished iron nails are coated with a reddish-brown deposit. Actually, the copper sulfate solution enters a chemical reaction with iron nails to form new products, that is, iron sulfate and copper.
Coming towards the next type of reaction, double displacement reaction. The reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reaction. For example, NaOH plus H2SO4 gives Na2SO4, that is sodium sulfate, plus H2O, that is water molecule. NaOH plus HCl, if react together, they give NaCl plus H2O. AgNO3 plus KCl, they give AgCl plus KNO3. Here you can observe that ions in the reactants are getting exchanged to form new products. This is a general form of the reaction, that is AB is a reactant, CD is a reactant, and when they react together, AC and BD are formed as product. This is general form of double displacement reaction. So let us quickly revise all these reactions. A plus B, that gives AB, means two reactants reacting together to give a single product. We call it as combination reaction. AB as a reactant, when reacts, it gives A plus B, that is, we call it as decomposition reaction. AB is getting decomposed in the product as A and B. The third type we studied was displacement reaction, that is A plus BC, it gives AC plus B is separated out. Here, in place of B, A has appeared. That means A has displaced B and we get a product as AC plus B. This is called as displacement reaction. And the last reaction that we studied was AB plus CD. It gives AC plus BD, which is double displacement reaction. Here, A is getting attached to C and B is getting attached to D. So this is how two reactants have moved from their place, and so we call this as double displacement reaction. So in this particular session, we studied about that what do you mean by physical change and a chemical change. As initially I said, many chemical changes are taking place in front of our eyes. Some are very slow and some are fast. But yes, they are taking place in front of our eyes. We also studied what do you mean by physical change. That is, the changes that are temporary and which are reversible. Then we come across how to write a chemical equation and how to balance this particular equation. We also studied different types of equations and we balanced them successfully. Let us quickly repeat all those points that when we are balancing a chemical reaction or when we are balancing a chemical equation, that time we have to see that whether the number of atoms on the reactant side are matching with the number of atoms to the product side. If it is so, our equation is balanced. If it is not, we can increase the number of molecules that are taking part in the chemical reaction, and accordingly we can make necessary changes to balance the chemical equation. Always remember that we are not going to change the molecular formula of any of the compound. We can just change the number of molecules that are taking part in the reaction. Then we had studied about the different types of chemical reactions. Again, combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. In the next session, we will be studying different more types of chemical reactions. Moving towards the next type of chemical reactions, endothermic reaction. Endothermic reaction is here heat is either absorbed from the surroundings or it is provided continuously from outside. That type of reaction is called as endothermic reaction. CaCO3 plus heat, that is heat we are providing from outside, it gives CaO, that is calcium oxide, plus CO2, that is carbon dioxide. Here you can see this is a type of endothermic reaction. Here heat is being absorbed from the surroundings and thus the reaction is getting completed. Another type of reaction is exothermic reaction. It means in this type of reaction, heat is liberated or given out when products are formed. And that's why the name exothermic. Thermic is the word which is used for heat. Exo means giving out. So exothermic reaction, again I repeat, in this type of reaction, heat is liberated when products are formed. Here example is CaO, that is calcium oxide, plus water, that is H2O. It gives calcium hydroxide, that is CaOH twice, plus heat is liberated. Here you can see the reaction that is taking place. Here is a comparison of exothermic and endothermic reactions. As I said, exo is heat giving out and endo means heat is taken in to complete this particular reaction. So thus we studied today the different types of chemical reactions based on nature as well as based on absorbing heat or giving out heat. Along with that, we studied how to balance the chemical equation and how to write it. In the next session, we will be studying some more interesting reactions in the same topic. So, till then, keep reading and keep practicing. Thank you.